Imagine, if you will, gaze upon these distant objects, it is literally seeing the past, witnessing events as they unfolded in the redshifted galaxies, stretched by the expansion of the universe, primarily emit their light in the infrared spectrum. However, to effectively detect and analyze this faint and incredibly distant light, JWST now, thanks to JWST, finally within our reach, promising a new era of cosmic discovery. The James Webb Space Telescope, or JWST, represents more than just a technological marvel. It's the culmination of decades of dreaming, planning, and relentless effort. Its journey began not with a launch, but with an idea, a vision to see deeper into the universe than ever before. This ambitious project involved countless scientists, engineers, and technicians all working in concert. Decades of meticulous planning and innovative engineering were poured into every aspect of the telescope, from its core design to the intricate mission parameters. At the heart of JWST are its giant mirror and sun shield. The mirror, composed of beryllium and coated in gold, is designed to capture faint infrared light from distant galaxies. The sun shield, a marvel of engineering in itself, protects the sensitive instruments from the heat and light of the sun, Earth, and Moon. To reach its destination a million miles from Earth, JWST had to overcome a significant hurdle: size. Its giant mirror and sun shield were simply too large to fit inside any existing rocket in their fully deployed state. Therefore, it had to be ingeniously folded to fit snugly inside the confines of a rocket fairing, a protective shell that shields the spacecraft during launch. This compact configuration was only temporary. Once in space, JWST would have to execute a precisely choreographed sequence to unfold perfectly, a complex ballet of motors, gears, and unfolding panels. The stakes were incredibly high, with no room for error in this intricate unfolding process. A single misstep could jeopardize the entire mission, rendering the telescope useless. The world held its breath as the launch date approached. On Christmas Day 2021, a day typically reserved for family and celebration, the world watched with anticipation and hope. JWS embarked on its journey, launching atop a powerful Ariane 5 rocket from the spaceport in French Guiana. The launch marked the beginning of a new era in astronomy. The launch itself was flawless, a testament to the skill and precision of the launch team. The rocket soared into the sky, carrying JWST towards its distant destination. But the launch was only the first step. The real test, the most challenging part of the mission, was just beginning. Over the next 29 days, a carefully orchestrated sequence of events would unfold. JWS had to perform a complex series of deployments, a delicate and intricate dance of engineering. Each step was critical, each one representing a potential point of failure that could compromise the entire mission. The world watched with bated breath as the deployment sequence unfolded. First, the solar panels and antennas deployed, providing the telescope with power and communication capabilities. Then, the delicate sunshield, a multi-layered marvel of engineering, unfurled layer by layer, shielding the telescope from the sun's heat and allowing it to cool to its operating temperature. Finally, the primary mirror unfolded, its golden segments clicking into place with remarkable precision. The segments then began aligning with nanometer precision, a feat of engineering that ensured the telescope would deliver the sharpest images possible. Back on Earth, engineers spent months meticulously fine-tuning the telescope, calibrating its instruments, and preparing it for its scientific mission. The telescope gradually cooled to its incredibly low operating temperature, a crucial step for observing infrared light. The moment everyone had been waiting for finally arrived. When the first images arrived, transmitted across millions of miles of space, they were breathtaking, sharper, deeper, and more revealing than anything humanity had ever seen before. A wave of relief and celebration swept through the scientific community, a testament to the years of hard work and dedication that had made this moment possible. JWS was finally ready to fulfill its destiny. Our time machine to the early universe was open for business, ready to unlock the secrets of cosmic dawn. The adventure had truly begun, and the universe was about to reveal its hidden wonders. Humanity had a new eye on the cosmos, an eye that could see further back in time and deeper into the mysteries of the universe than ever before. With JWS's golden eye finally open and gazing into the vast expanse of space, a new era of astronomical discovery began. Its advanced technology promised to unveil secrets of the cosmos previously hidden from our view. Astronomers, eager to test the limits of this new instrument, set out on a quest to find the universe's first light, the faint glimmer of stars born in the immediate aftermath of the Big Bang. They prepared to sift through the data, searching for the faintest signals from the most distant objects. The telescope's primary mission, to witness the end of the cosmic dark ages, that period after the Big Bang when the universe was opaque and filled with neutral hydrogen. JWST was designed to observe the birth of the first stars and galaxies, capturing the moment when the universe transitioned from darkness to light, from simplicity to complexity. Scientists anticipated that the earliest galaxies would be small, irregular, and relatively faint. Cosmic toddlers, still in their infancy, just learning to walk and assemble themselves from the primordial gas and dust. These were expected to be the building blocks of the larger galaxies we see today. Instead, JWST's first breathtaking images revealed something entirely unexpected. It showed a universe teeming and packed with thousands upon thousands of galaxies, stretching back to the dawn of time. Each galaxy, a sprawling metropolis, a city of billions upon billions of stars, shining brightly across the vast cosmic distances. Astonishingly, some of these galaxies appeared to have formed just 500 million years after the Big Bang, a blink of an eye in cosmic terms. The biggest surprise? Many of these early galaxies were already remarkably large, incredibly bright, and surprisingly well-formed, far more mature and developed than any existing theoretical models had predicted. The universe's baby pictures, taken in its earliest infancy, looked less like snapshots of newborns and more like detailed portraits of fully grown adults. JWST was not simply meeting the high expectations set for it, it was completely shattering them, rewriting our understanding of the cosmos. The early universe, as revealed by JWST, was far more crowded and active, and significantly more complex in its structure and evolution than anyone had previously imagined. A profound cosmic mystery was now rapidly unfolding before our very eyes, challenging our fundamental understanding of the universe. In 2025, JWST captured a jaw-dropping sight, two massive galaxies colliding just a few 100 million years after the Big Bang. These weren't primitive tiny galaxies. They were giants, each with billions of stars and complex structures. Even more astonishing, both harbored supermassive black holes millions of times the mass of our Sun. According to existing theories, there simply hadn't been enough time for such massive galaxies or black holes to form. It was like finding a fully grown tree just days after planting a seed. This impossible encounter forced scientists to rethink everything about how galaxies and black holes grow. The universe, it seemed, was building its grandest structures at breakneck speed. The cosmic timeline needed a rewrite. The standard model of cosmology, called lambda cold dark matter, predicts a slow, bottom-up growth of galaxies. Small galaxies form first, merging over billions of years to create larger ones. Supermassive black holes, too, should take eons to grow from tiny seeds. Yet, JWST found enormous galaxies and black holes when the universe was still in its infancy. The evidence directly contradicted the rulebook. It was as if the universe had skipped steps, assembling castles from bricks almost instantly. The presence of these impossible galaxies meant our understanding was incomplete. Theories about galaxy and black hole formation were suddenly up for debate. The universe was building faster and more efficiently than anyone thought possible. The cosmic puzzle had just become much more intriguing. Faced with these discoveries, scientists began searching for new explanations. One idea, maybe some black holes formed directly from massive gas clouds, skipping the small seed stage. Another, perhaps rivers of cold gas funneled into young galaxies, fueling rapid star and black hole growth. Some even questioned whether dark matter behaved differently in the early universe. These bold theories suggest the early cosmos was far more dynamic and efficient than we imagined. JWST's findings have opened a new era in cosmology, one where old rules are being rewritten. The impossible encounter wasn't the end of the story but the start of a thrilling new chapter. The universe was challenging us to think bigger. JWST's discoveries didn't stop at massive galaxies. In one image, astronomers spotted a glowing question mark shape, created by merging galaxies in the distant universe. This cosmic punctuation mark became a symbol of our curiosity and the mystery still unsolved. The shape was formed by tidal forces stretching and warping galaxies as they collided. By studying these shapes, astronomers can reconstruct the history of galactic mergers. The universe, it seems, is full of questions, both literal and figurative. Every new image from JWST brings answers, but even more profound questions. The cosmos is asking us to keep exploring. Galaxy mergers are not just spectacular, they're essential to cosmic evolution. When galaxies collide, gravity triggers bursts of star formation and feeds supermassive black holes. These starbursts can create millions of new stars in a short time. Mergers also drive gas into galactic centers, fueling black holes and lighting up quasars. The impossible encounter showed this process happening much earlier and on a grander scale than expected. Collisions build bigger galaxies, ignite new stars, and grow the universe's largest black holes. The early universe was a place of rapid, violent change. JWST revealed that cosmic creation was driven by spectacular collisions from the very beginning. The universe's most magnificent structures were forged in chaos. JWST's discoveries have forced us to reimagine the universe's early years. The story of slow, steady growth has been replaced by one of explosive, accelerated creation. The impossible galaxies are clues to new physics and deeper mysteries. Questions about dark matter, black hole formation, and star birth are now at the forefront of science. JWST will keep searching, revealing more surprises and rewriting our cosmic story. For the next generation of scientists and dreamers, the universe is more mysterious and wonderful than ever. The data from JWST is a treasure chest waiting to be unlocked. The journey of discovery is just beginning. With every new image, we peel back another layer of the universe's past, the adventure continues, and the view is breathtaking.